Hello, welcome to another maths video by Maths with Sarah. Today we're going to be looking at this question. So typically I take my questions from GCSE maths papers, but I saw this really nice one from one of the New Zealand equivalent GCSE papers. So it's actually an NCEA Level 1 maths, which is the equivalent of GCSE. Comes from their geometry paper. And I thought that it was really nice. So it uses Pythagoras, but it really makes you think about how you're using Pythagoras and what parts you need to find out. So although it doesn't come from a specific GCSE paper, I actually think there's a lot of benefit in looking at some of the other exam boards and some of the other country papers, because the level of qualification is normally fairly similar. But the questions can be worded quite differently. So I think if you want to challenge yourself, this is a really good way of going about it. Okay, so let's get started with this part of the question. So this is just one snapshot of it, just one part of the question. But there are a number of different steps that we need to work out. So we have been given, this is talking about some sails on a boat, and we've got the normal standard sail and the expanded sail. And what it wants us to work out is to calculate G, this length here. So not the total length, but just this length here, the length of the crossbeam that they put in G here. So we have quite a lot of information on this diagram. We know we've got a right angle here, and we've got various lengths. So, and we've also got triangles. So in terms of working out what we are going to use, so one of the things that I always say to my students if I'm teaching them in person or on Zoom is that you look first at what you do know. What information have you been given? If you're looking at this question thinking, where do I even start? One of the really good points is to write down what you do actually know. So we've been given various lengths. We've got a right angle. We've got other lengths that we need to find out. There are no angles involved at all. And that should hopefully give us a little bit of a clue that we're probably going to be using Pythagoras. We've not got any angles, so we can't really do any trigonometry. We know that it's a triangle. So let's start by writing out the equation that we use for Pythagoras. So we've got c squared equals a squared plus b squared. And then we can hopefully look on the diagram that we've got and work out what might be, for example, C, what might be A, and what we can use to kind of work out various other lengths. So we know that C is always the hypotenuse, or the side that is opposite the right angle. So we know that this is C and also this is C, because we can see we've got this big triangle here from M to N to Q, this big triangle, and then this smaller triangle here, which is N to P to M, this smaller one here. So for the larger triangle, we've got an unknown here and we've got an unknown here. So we don't actually know what this length is, and we don't know what this length is. So there's not a huge amount we can really do with that at the moment until we've worked out at least one of the side lengths that are currently unknown. But for this slightly smaller triangle from N to P to N to M to P, we have got two of the side lengths known. So we can call this one, for example, A, and this height one we can just call B for the time being. So hopefully you can see that now, as we've got two side lengths, we can hopefully figure out what the third one is. So we know that this one is going to be C. So we can do C squared, subtract A squared to figure out what B squared is going to equal. So from that, we can do 8 squared minus 4.9 squared. And then if we square root the whole thing, that will tell us what B is. So if you were to put this into a calculator, you would end up with B equals 6.32 meters. Okay, now I think some of my students get very fed up with me always asking this, but my next question would always be, does this value make sense? So if we were to say that if we were putting in this value of 6.3 meters, Does that make sense with the rest of the question? And in this case, yes, it does. We've got values of 8 meters, roughly 5 meters. So a height of 6 meters does definitely make sense. But hopefully, if you were to get, say, 600 meters, you would be questioning that you maybe made a mistake with your maths somewhere. Okay, so we've got a C, we've got, we know what this height is now. And that was one of the unknowns that we weren't sure about. And we couldn't figure out what G was yet, or what this total side length was, until we figured out the height. So now we have got a value for C, a value for B, and that will allow us to work out this total length of this side. So we can call this one A for now. So we can apply exactly the same again, do Pythagoras for a second time. So this time we can do, it will be C squared minus B squared, because we don't, A is the one that we're trying to find out, and that will give us a value for A squared. So if we start substituting in some of these values, we know that C is now 11 because we're now using the big triangle. So we've used a small triangle to work out what the height is. Both of them share the same height. So now we can use the larger triangle values. So this will be 11 squared minus B squared, which is 6.32 squared. And then if we square root the whole thing, that will give us a value for A. So A will be this total side length. So if you work this out, if you pop this into a calculator, you will get a value of A equals 9. So A equals 9 meters. Again, just do a very quick check in your head that's a value that actually makes sense. So we know that we've got a height of 6 meters. We've got this, the hypotenuse is 11 meters. So we're probably expecting something that's less than 11 meters and close to 6 meters. We've got 9 meters. Yeah, that fits the bill. We can be pretty happy that that's correct. So now we want to work out what G is. So G is only part of A. So in order to work out what G is, we need to do A, or the 9 meters, subtract 4.9 meters. Again, if you work this out, you get a value of 4.1 meters. And that will be our final answer for G. So quite a lot of different steps. Obviously, having 2 triangles, you kind of had to realize that you needed to use the small triangle to work out the height that you needed to make the calculation for the large triangle. So it's definitely not a straightforward question. Just by having a couple of steps, it just makes it a little bit more difficult. But hopefully, if you were maybe not feeling too confident with Pythagoras, this has helped you out. So I'm going to be doing a few more questions from these NCEA Level 1 papers, just because I think they tackle questions. They have questions that you have to tackle slightly differently. So I'm going to grab a few questions from there for the next few videos. So make sure you like and subscribe so that you know what's coming up next. Thanks for watching.